Hey everybody, welcome back to this channel. Today we're gonna talk about a readable stream. So we already talked about writable stream and types of streams. So let's start with this readable stream. There are some of the characteristics that are in common with writable stream, but the readable stream had their own uniqueness. If we take a close look at the readable stream, they have two modes. One is a flowing mode, one is non-flowing mode or paused mode. So how to I just explain it to you. What is a flowing mode? So flowing mode means that take a look at this diagram. So we have readable stream, and we have our underlying resources, for example, a file system and other so-called underlying resources. So the data from underlying resources will be automatically pushed to the readable stream with default length 16 kilobytes. And then if as a consumer, we have to use a readable stream to manipulate the underlying resources for data. So we have we have to push the internal buffer data from the internal buffer to your application. That's mean this, right? This, sorry. This step. So these two steps are independent, and in flowing mode, the two steps are automatic. So you don't need to write a specific code for this action, push action. So data will be automatically pushed to your application. So how to trigger to flowing mode? Because when you create your readable stream or initiate this readable stream, by default, it stays in the non-flowing mode. And how to trigger this to enter into the flowing mode by adding event data and a callback have to be given. And also, if you call pipe, function pipe or method pipe or just pipe your readable and the calling resume. So they can resume from non-flowing to flowing. So kind of like everything is automatic. So it's you can say that it is, I'd say, less flexible for this flowing mode, but you can use it appropriately. Another mode is non-flowing mode, is pause mode. So in pause mode, you have to you can compare this to this picture with the previous one. If you have to if you want to use the data from internal buffer readable within the readable stream, you have to pull manually. You have to pull it out manually. So by using the stream read method to pull the data to your application. So this is a different point or between non-flowing and the flowing. And how to trigger non-flowing, how to enter this non-flowing mode by one of the options is by using even readable, and by calling the stream pause. When you stream paused, it goes into this non-flowing mode, and you call unpipe. So you just tear down you pipe connections, you unpipe some your readable stream or writable stream close to the readable stream, and it automatically goes to the non-flowing mode. So because there's a lot of manual operation and manipulation you can use, so kind of like there's more flexibility here. So besides 2 modes, we also have 3 mode states surrounding with this readable flowing method, flowing mode or non-flowing mode. Because when we look at this diagram, we have 3 states, mode states. So it means readable flowing equals state none, state true equals true and equals false. So at the beginning, this is a equals none, and the readable stream not generating any data. So when you are giving a data event or pipe or just resume, we talked about these 3 options, and they turn to true. So the readable stream start generating events and generating data. This is a flowing mode equals true. This is a flowing mode. When you give a pause or unpipe, or it receives back pressures, it goes to the false state. So kind of like a hoarding the flowing event, but the generating data is still continuing. And inversely, we have this state a readable stream with this state, when it removes back pressure, it goes back to the normal, and they turn to the true mode and to the true flowing mode. So it's kind of like a pause, unpause, or resume, and removing back pressure, receiving back pressure. There are 3 states coming around. And if you want to read more detail, you can refer to the official document. Here is 2 reading modes and 3 states. So you can take a close look at that and read some details. And if we want to do something or finish some tasks on the flowing mode, here's an example. We just grab a readable stream as an instance and just give them a data event, define data event, and give it a callback. And the trunk means the flowing mode. This data automatically pulled data, which is a trunk, parameter trunk. So you can manipulate or display the trunk within your application. So for non-flowing mode is or pause mode, you have to use read method and the size as optional. Parameter size will be optional. When, as I said, when the buffer has data, readable events fire. So you have to define new readable event. So within the readable events, you have to use read method must be called. So you can give the size, you can leave it blank. Size is optional. So there's some rules here. If the size argument not specified, all the data contained in the internal buffer will be returned. So you read once, so all the data within in the readable stream internal buffer will be read out to your application, your own application. So, but size limits will be 1 GB for one read. And please note that only in non-flowing mode read can be used, because in flowing mode, the action of reading something will be automatic. You don't need to invoke read function. So for about optional size of argument, if you give this size, that means you for one for read action, for every read action, so a specific number byte will be read from internal buffer. If the side bytes are not available to be read, for example, you give the size is equal to 1600 or 16,000, but the size in a size byte in the internal buffer is less than 1600, 16,000, and so the side byte are not available to be read, or none will be returned. None will be returned. Unless this is the last stream has ended. This is the last read. That means if you specify the size, but the internal buffer is less than, the size of the internal buffer is less than your specific size, that means none will be returned. So be careful this rule. None will be returned. Especially for if you if you have some if condition for based on this returning value. Okay, let's get started with some of the snippets, and to show you how to define the flowing mode, how to define a non-flowing mode, and some of the fundamental operation readable stream. First, we're gonna go through the flowing mode, readable string. So here is my snippet. So I think it's pretty simple. Just as a review, and we have a, you know, we have instantiate a readable stream, then we gave it a data event. So here we just comment out this and enable this. So the whole snippet is to read this test.tsd and display the content on your screen, and just okay, very simple. So and we console log some important variables right here. The readable flowing. Remember, we have the three readable flowing values: non, true, and false. So we keep track of this variable value, and also console log out this readable buffer. This, which is internal buffers, it gave us a content the readable internal readable buffer, and yeah, that's okay. Just run it, and the second part of it, just another type of thing tag for so how to write this readable stream with flowing mode with a iterator, with async and await. Also pretty simple, because every stream or readable stream is a kind of iterator, so you can iterate them, and so just execute the .next. So when you execute every .next, so the trunk will come out, and you can so leverage this chunk to to have your own application. I just run it, so you can hear where this is output. So first we have a non. Non means we just print out the readable flowing mode. The value of the readable flowing is a non because the default value, and the buffer list, and then here is this one, rs readable buffer. So at this time, at the beginning is empty internal buffer, and when the data automatically push to your application, and your data event triggered, and this callback will be called, and here's the console log, and just match to this output. So file size and size right here. Let me check. Oh. Okay. This one. So here file size and 64 64K kilobytes being read, and the size, so readable flowing. The value of the readable flowing is true now. So that means here we are using a flow, we are in a flowing mode, and this is a internal buffer is 0 because we read up or eat up all the 65 internal buffers value data. And second is 128 kilobytes true buffer. So this number is accumulated because the size is accumulated, so it's growing by 64 bytes. You can see, and scroll down to the end, we have our file, which is in size 32 mega. So all of the data from this file was eaten up. So the internal buffer was eaten up. So everything is read out and everything was used by your application and displayed. Yeah, that's the flowing mode. And just comment out this event and by using this as a substitute. So by using the iterator, so we can see this function is the same, but we have two types of syntax. We read chunk. This chunk is 64 bytes, kilobytes, and the buffer is still 0. And the internal buffer is empty when after you read. So by reading all of the data one by one, and we have finally there's no more data, so everything will be consumed. So that's a flowing mode. Read. Okay. Let's get over to our non-flowing mode. So here is a snippet for non-flowing mode or pause mode. So we can use our own read method to manually pull the data into your application. So this is a different point from the previous one, flowing mode. So let's take a look at this snippet. First, we just instantiate a readable stream and give it a name as RS, a readable stream. And be careful with this. We just define a high watermark equal to 70, because as before, we have our 16K kilobyte high watermark. So we just want to show you something interesting. So I just give it a small number with 70. So, and we as before, we console log as many parameters and variables as we can to show you the mechanism behind the scene. And we have a set timeout, a synchronous flip here. So we define a readable because when you manipulate the non-flowing mode, you have to give readable event. And in this readable event, we have a callback to show some tips. For example, before read, we have to show our internal buffer, what it looks like, and after read, because after read this line. So rs.read, and I give it 65 as a parameter. So it means I read every time I read this internal buffer only with 65 bytes to our application. And we just here we just have a condition to decide if it's a none or not, because if I should, for example, if the internal buffer has less than 65 bytes of data, so that means it returns a none, because there's not enough to read 65 bytes. And then if the internal buffer has the data more than 65 bytes, so there's an iteration here. It's a loop, so it just circle around and read as much as possible. And after read, we just after read, blah blah blah, show you the internal buffer, the status, and this here is the end event. So that's the whole program. We run it. Here we have our output. Let's look at this together. And here we have a none. None means we have a initial a flowing mode variable, which is the initial, and this is initial internal buffer, which is 0 length. And before read, internal buffer has one length of one, has a one chunk in the internal buffer, because readable stream just automatically read 70 bytes from the underlying resources, which is file system, which is this file. I'll show you this file. So this file is, you can think of this file as underlying resources. So readable resource rs, this rs will read this file only with 65 bytes every time. So that means every chunk in our buffer is 70 bytes. So then our readable events was triggered, and the stream is readable, and we read this 65, because we give it a size is 65. That means there's 5 bytes left in the internal buffer. So this iteration only executed once, because in the second round, when we calculate this, trunk is none, because there's not enough data to to be read because there were only 5 bytes left in the internal buffer. So you can see the ACC, that means the iteration, the number of the iteration. So ACC always equals to 1, is equal to 1 because they only run 1 time. And then they got none. And then after read, they still have one chunk because as I said, there were 5 bytes left in this chunk. And at that time, another 70 bytes data has been read from the underlining. So before read, the buffer will be increasing to 2, or buffer will be increasing to 2. There were 2 chunks in it. So stream, another readable trigger, another readable event has been triggered, and this code has been executed again and still read 65 bytes. And after read, still have one chunk because this is second round. So we the program read 65, and we have how many bytes were left in the internal buffer? 10, because 5 plus 5 equals 10, right? So it combined 5 bytes to a single chunk. So that means if you take a close look at the buffer list, the infrastructure of the buffer list, it's a complicated data structure because they have to keep track of every chunk's head and toe, the sequential number, all of the things. And that means that with the increase of our internal buffer, and we continue read from the underlining resources from this file. So everything just occurred again, but remember the file, every time the 5 bytes, another 5 bytes were left. So after how many times do we have this 5 left, 5 bytes accumulated to a big chunk, accumulated to 65, the full chunk. So you can see the 16 times 5 times 16 equals to 65. So after 16 times accumulating, blah, 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 you can see I scroll down. As I scroll down, look at this. Here we have another 65 bytes to iterate. So here we have 2 iterations because the accumulated data is enough to make another round. So that means we the program iterate twice again, twice. Then after read, our internal buffer has been eaten up. So the length was 0. I think I get through to you. So that means this is accumulation process after certain time. The accumulation, the iteration. So the 65, we accumulated the whole 65 bytes, so we can eat up all the 65 bytes. So that right this time, so the internal buffer will be consumed fully or thoroughly. So then, and then the next again, the same thing happened again. So accumulated again, grow. So internal buffer remaining bytes growing to became another 65 bytes, or like this to the file end, to the stream end. That's the whole theory or of this small snippets. You can, if you want to practice yourself, you can modify this number, you can delete this number, and you can modify this parameter, high watermark, to see what it looks like. Okay, that's non-flowing mode. So you have to explicitly read, manually pull the data to your application, and you can control how many bytes you want to pull. So that's it.